let's start with a new chapter, which is algebraic expressions and identities. So what are algebraic expressions and what are identities? So we've seen a lot of equations and different forms of equations, like we have seen an equation where it goes like x square plus 2x. We could see an equation like 2x cube, right? All these are equations. I could write 4x cube plus 9x square plus 8x plus 12. Again, this is an equation, right? So whenever we get a statement, when we are converting it into a mathematical statement, like when we are converting a statement to a mathematical form, we use different types of variables and constants to define an equation, right? So we've seen solving word problems by using mathematical forms of the same equations. Now let's dive deep into this form where about algebraic expressions and identities. Now, let's talk about constants and variables. So what is a constant? So a constant is anything which have a constant value all the time. So no matter what the equation is, 1 have the value of 1, 2 have the value of 2, 3 have the value of 3. And if I'm saying that, there's half of something, the half is a constant, right? So a value which doesn't change is called a constant. Now, what are variables? Variables are the values that change. We could hear it said that, consider variable as a container that can hold different values, right? Variable is a container which can hold various values. Like you could put in one value and you will get some other result, right? So let's say if we have an equation 2x square, if I'm putting x is equal to 1, 2x square would be equal to 2 into 1 square, which would be equal to 2. Now, if I'm putting 2 here, we'll get 2 into x square is equal to 2 into 2 square, which would be equal to 2 into 4, which is 8. Now, if I'm putting 3 here, I'll get 2 into x square is equal to 2 into 3 the whole square. 3 square is 9 and 9 2s are 18. So, here the variable is x, right? That is, we're changing the values of x here in this equation. So, I hope that you're clear with what is constant and what is variable. Now let's move on to the next topic, which is algebraic expressions. An algebraic expression is a mathematical phrase or a sentence that uses numbers, letters called as variables, and mathematical operations like addition, subtraction, multiplication, and division. It is a way to show the relationships and solve problem in more general form, right? So basically, what are algebraic equations? That is anything which have a number and some alphabets, like, right? Now, this might have mathematical operations like here we have multiplication, we could add in division, we could add in subtraction or anything. Now, why is this used? To solve problems, right? To form problems in a more general way where we are assuming variables. Like instead of saying one thing, we are talking about what will happen in general. Now, let's actually look into what all are the constituents of an algebraic expression, like what makes an algebraic expression. We have terms. A term is a combination of a constant and a variable multiplied together. For example, 2x is a term where 2 is the coefficient and x is the variable. So here what is explained as a term? So if I say that 4 into x square, is this a term? Yes, it is a term where 4 is the coefficient, right, with x square as the variable. X is the variable actually and 4 is the coefficient. And if 2x is a term, 2 is the coefficient and x is the variable. So when there is a combination of a variable and a coefficient of the variable, which is normally a constant, we have something called a term. Now, like terms. Terms that have same variable raised to the same power is called like variable. That means we can combine them together in an equation. Let's say here it's given 2x and 5x as same term, like terms, because they have both the variable is x. Now let's say if we have a term 2x and another variable 2x square, are they like terms? No, they are not. Why? Because the degree of variable is 1 here and the degree is 2 here. It's raised to different powers. Now, if I say that I have 4x cube and 3x raised to 3, Are they like terms? Yes, they are like term. Why? Because we have both the variables to be x raised to 3. Now we could actually add these two numbers. We could get 7x cube. Now that is one property of like terms, that we could actually add or subtract both of these numbers. Now let's move on to the next topic, which are unlike terms. So it's very obvious if we talked about like terms. So it's very obvious what is an unlike term when you hear about like terms, right? So in order to add or multiply two terms, we have the both of them have to be similar. By similar, I mean that both of them should have a similar variable, like the power of the variable should be same for two numbers to add or subtract them. So unlike terms, it's like if I'm asking you to add x square and x together, it's just like asking you to add apples and oranges together. Like that makes, that doesn't make that much of a sense, but like we can't add different things together in algebraic expressions, right? If I have to add x with 4x, it's possible, we'll get 5x. But can I add x with 8x square? No, we cannot, because they have different variables. So these are unlike terms. Now coefficients. Coefficients are numbers that multiply with variables. For example, in the term 3x, the coefficient is 3. It tells us how many times the variable x is multiplied. So basically, what do we mean when we write the term 3x? It means that it's 3 times x or 3 into x. So what are coefficients? The coefficients are the number which accompany the variables. Now, polynomial. A polynomial is an expression made up of variables like x or y or coefficients combined using addition, subtraction and multiplication. For instance, 2x square plus 3x plus 1 is a polynomial because it has 3 terms added together. So we have 3 terms added together, 3 or more terms, or even two terms, any term, 1, 2, 3, doesn't matter. We could call it a polynomial when we have a variable and a coefficient. If we have a variable and a coefficient together and they have like some operations going on, like addition, subtraction, multiplication, division, anything could be a polynomial, right? Now let's talk about the types of polynomials, okay? These are the types of polynomial. The first one is monomial. A monomial is a type of polynomial that have only one term. So if I say 4x, it's actually a polynomial. But what type of polynomial? It's actually a monomial. Why? It have only one term. Mono means one. So basically when we have one term, we call it a monomial. Now if I say here it's given 7y squared. What is this? It's again a monomial. You can't say that 7 into y squared, there are two terms. No, it's not fair. This is the coefficient of this term. So it's actually one term. One term it is. So this is a monomial, right? Now let's talk about binomials. So we talked about polynomials and then we told about monomials. So monomials are polynomials with one term. So what would be binomial? Bi means two. So a binomial is another type of polynomials that have two terms, right? So if we have 2x plus 5y, it's a binomial. If I have 8x square plus 3x, it's another binomial, right? I hope that's clear. Now let's move on to trinomial. A trinomial is a polynomial with three terms. For example, 3x square plus 2x plus 1 is a trinomial. So if we have three terms, just like this, if we add one more term to it, it becomes a trinomial. We also have something called a quadrinomial. What is a quadrinomial? If we add one more term to the trinomial, we get a quadrinomial. Here an example is given, that is 2x cube plus 4x square minus 3x plus 1. This symbol, it's when we write it like this, it means that it's 2x cube. Okay, now 4x square minus 3x plus 1 is a quadrinomial. Now, degree of a polynomial. Imagine you have some mathematical expressions with numbers and letters like x and y. These expressions are called polynomials. Now, the degree of a polynomial tells us the highest power of the variable that appears in the expression. See, if we are talking about various expressions, like I could say 4x square plus 8x plus 12, right? So what is the highest power of the variable? Here we know that the variable is x, right? So what is the highest power which x have? Here the power of x is 1 and here the power of x is 2. So the degree of this equation, is equal to 2 here. At the same way, if we have an equation like 8x cube plus 4x square plus 8x plus 12, if this is an equation, what is the highest power of the variable? The variable is x and the highest power is 3. So the degree of this equation would be equal to 3. Now, degree of a polynomial in one variable. For a polynomial in one variable, the highest power of the variable is called the degree of the polynomial. We were talking about the polynomial in one variable, right? We just have x as the variable here. So the highest power goes as the degree of the polynomial. Now, degree of a polynomial in two or more variables. For a polynomial in more than one variable, the sum of powers of the variables in each term is taken up as the highest sum, so obtained is called the degree of the polynomial. So if I have x cube and y square, right? For a polynomial in more than one variable, the sum of power of the variable in each term. So sum of power of variable in each term means 3 plus 2 is equal to 5, right? And the highest sum so obtained is called the degree of the polynomial, right? If we have x cube minus 4x square plus y square minus y plus x is equal to 0. Now, what is the degree? We take the highest of both variables, we add the powers, which is 3 plus 2, which is 5. The degree of the equation becomes 5, right? Now, let's actually look up to some fundamental operations of polynomials. First of all, let's talk about how to add two polynomials, right? So, when we are adding polynomials, only one thing we have to make sure is that they have the same variables. So, if I have an equation 4x square plus 3x plus 2 and I have another equation which I have to add with this equation, which is 6x square plus 8 plus 4x, right? How do we add this? So basically, when we are adding these two equations, let's look at the variables first. So coefficient of x square adds with the coefficient of the other x square. So I have x square and 6 plus 4 is 10 plus I have 3x and 4x. So x I'll have there and 3 plus 4 is 7. Then I have 2 and 8 with no variable. So 2 plus 8 is 10. So this is how we add two polynomials, right? Now let's look into the subtraction of polynomials. First, look at the terms. Like terms are the ones with the same variables and same power. So basically what we're doing is we'll sort out two like terms, like these two are like terms, these two are like terms and these two are like terms, right? Now we'll subtract each of the pair. Just like we did with additions, let's do this. Let's do the opposite, which is 6x square plus 8 plus 4x minus 4x square plus 3x plus 2. What do we get? We have like terms. What are the like terms? We have 6x square and 4x square. Then we have 4x and 3x. Then we have 8 and 2. So what is 6x square minus 4x? It's 2x square. What is 4x minus 3x? It's x. And 8 minus 2 is 6. So this is how we subtract a polynomial. Now let's talk about the multiplication of polynomial, right? Now, if I am multiplying a polynomial like x minus 4, or let's say x square plus x minus 4 into, I'm multiplying it with any one term, right? If I have one term which is multiplying with it, let's say x or a, let's take a. We have ax square plus ax minus 4a, right? Because I'm multiplying each and every term with the single term, right? Now let's see if I have two terms. I have a and b into, let's say, a plus b, right? Now what does this become? So if I'm taking a plus b, I have to multiply each of these terms with each of these terms from the second part. So I'll multiply each of the term of the first, right, first polynomial with a. So I'll get the same answer here, ax square plus ax minus 4a, right? I kept it there. Now I have a plus here, so I'll put the plus. Then I'll multiply b with every single term. So it will go from b and this term, b with this term, and b with this term, right? So we'll get x bx square plus bx minus 4b, right? So this would be the answer for this question. Or we could expand this where we'll get ax square plus ax minus 4a plus bx square plus bx minus 4b, right? Now let's take the like terms together. We have ax square plus bx square, and we have plus ax plus bx, and I have minus 4a minus 4b, right? Here I could take x square to be common, right? X square I'm taking it as common. I have reminding with a plus b, and I'll put the plus sign. Here I could take x as common. I'll take x as common, and again I'll get an a plus b here, right? Now I'm taking minus 4 as common from here. I get minus 4 as common, and again I'll get plus a plus b, right? Now I could take a plus b as common from all three of these, and I'll get a plus b into x square plus x minus 4. Where did we reach? We reached the starting, right? This is where we started. So this is actually the proof, and this is the multiplication. Now let's move on to the division of polynomials. So division of polynomials is a little bit tricky, right? So we could actually divide it into three parts. First is division of a monomial by a monomial, then we'll get into division of a polynomial by a monomial, and then we'll talk about division of a polynomial by a polynomial, right? Now let's get into the division of monomial by a monomial. So what is a monomial? The term which have one term, right? So I have 14x square y here and 7x here. So what is 7 and 14? We could cancel this out from here, which is 2, and x and x would cancel out, which will give us xy, right? Dividing monomials refers to the division of coefficients of the two given monomials and division of the variables separately and then combining them to get the result. So consider the coefficients and variables separately. Here we have an example where 14x square y divided by 7x. We could elaborate this and do this, right? We could take the coefficients together, that is 14 by 7, we could do it separately. This would be 2xy, right? 14 by 7 could be done separately, which will give us 2. And then we have x square y by y, right? So x square y by y means we have x square into y raised to minus 1 is here, y. We have, this is x, so we have x, we have 1 by x here, right? So 1 by x is x raised to minus 1, so this becomes x square y into x raised to minus 1, which would be equal to x raised to 2 minus 1 into y, which is x raised to 1 into y, which gives us xy, and then we combine these two, 2 and xy, so we'll get 2xy. Right? This is a very easy things to do. You could just cancel out whatever you have in a monomial, right? You could just cancel out the common terms and you will get the answer. Now, division of a polynomial by a monomial. So when we are dividing a polynomial by a monomial, what we do is, like, if we have a polynomial here which is 4x square plus 8x plus 12. Let's say we have a polynomial like this, and we are dividing it by a monomial which is 4x, right? Now, if we are dividing it, how much times 4x is 4x square? We have x times 4x is 4x square, right? Now, this is 0 and we have 8x plus 12 left. Now, how much times 4x is 8x? We'll do the next term. Well, how much times 4x is 8x? 2 times 4x is 8x, right? Now, we have 12, right? So, here we're just, stuck here because, we don't have any other things. We'll just add 0, 4x, and we have same. We can't do anything, and we have 12 as the balance. So this is the quotient, this is the remainder, and this is the divisor. So how do we express it? X plus 2 is the quotient plus this divided by 4x, remainder by divisor, right? That's how we express. So we could expand it and we'll get the form, right? Now, division of a polynomial by a polynomial. For dividing a polynomial with another polynomial, the polynomial is written in the standard forms, that is in terms of dividend and divisor, and arranged in decreases order of the degrees. We would never write this as 8x plus x plus 4x square. No, this is a wrong way of writing it, right? We'll actually arrange it according to the power of the variables. Now, the method to solve these types of division is long division. In algebra, an algorithm for dividing a polynomial by another of the polynomial of same or lower degree is called polynomial long division. It is the generalized version of familiar arithmetic technique called long division. We have studied about long division, right? So, it's basically the same thing in the algebraic way. Now, let's talk about identities. Polynomial identity refers to an equation that is always true, irrespective of the variable values. We use polynomial identities while factorizing the polynomial or expanding the polynomial. So, we have different identities in polynomial. So, we have seen about this identity, which is a plus b the whole square. Everybody knows what a plus b the whole square is, right? Which is equal to a square plus 2ab plus b square, right? So, what is a square plus 2ab plus b square? A plus b the whole square. No matter what the values of a and b are, this equation always holds true for this, right? So, we have, let's put the values of a is equal to 1 and b is equal to 2. 1 plus 2 the whole square is equal to 1 square plus 2 into 1 into 2 plus 2 square, which is 1 plus 2 2s are 4 plus 2 square is 4. You get 4 plus 4 is 8 plus 1 is 9, right? So, what is 1 plus 2? 3, and 3 square is actually 9. With the small numbers, we could actually find the squares, but when it comes to larger numbers, this method is very useful to solve, right? Now, let's look into these kind of things are called identities in an algebraic equation. Now, let's look into different identities which we use for solving problems in algebraic equations. Now, first we have our a plus b whole square is equal to a square plus 2ab plus b square, right? Now, what did we do here? So, we know that a plus b the whole square is equal to a square plus 2ab plus b square, right? Now, if I am multiplying negative everywhere, what happens? We have minus a minus b the whole square. This is same as a plus b the whole square, right? Minus a and minus b and a plus b are the same here because it's the square, right? Now, a minus b the whole square is equal to a square minus 2ab plus b square. Now, this is a very important formula, which is a plus b into a minus b is equal to a square minus b square. This is a very important identity. That is, if we get a number like x square minus 4, we could actually split this up as x square minus 2 square, which would be equal to x plus 2 into x minus 2. Now, we have a plus b plus c the whole square. Now, what if we have three terms? Here we had a plus b the whole square, we have a plus b plus c the whole square, we have a square plus b square plus c square plus 2ab plus 2bc plus 2ac, right? All the combinations. Now, if you have one subtraction, we will get all the squares, then 2ab would be positive and any terms involving with c would be negative. Now, same thing if it's with b, any terms involving with b will be negative and all others remains the constant. If it's minus a, again every term which includes a would be negative and all other terms would be positive. Now, what if it's a minus b minus c the whole square? So, we have a, b, c, a square plus b square plus c square as such. Now, when we are talking about a and b, a is positive and b is negative, so it becomes negative. Now, when we are talking about b, c, we have minus b and minus c, which gives us positive, right? Now, when we are talking about ac, we have plus a and minus c, which gives us negative. Now, let's talk about a plus b the whole cube. So, there is an equation given here which is a cube plus b cube plus 3ab into a plus b, right? If we are expanding this, what are we going to get? We will get a cube plus b cube plus 3a square b, right? And then we will get plus 3ab square, right? Now these are the expansions, and if it's a minus b the whole cube, we'll get a cube minus b cube minus 3ab into a minus b, right? Now a cube plus b cube. What is a cube plus b cube? It's equal to a plus b the whole cube minus 3ab a plus b. We did nothing. We know that a cube, a plus b the whole cube, we just said that it's a cube plus b cube plus 3ab into a plus b, right? Now what is a cube into b cube, a cube plus b cube? It's equal to a plus b the whole cube minus 3ab into a plus b, right? We just kept both of these terms together and took the term to the next side. That's what we did here, which is also equal to a plus b into a square minus ab plus b square. So what happened here? We took a plus b outside, right? So when we take a plus b outside, what do we have left? See, this is the equation, a plus b the whole cube minus, let's write it here, we have a plus b the whole cube minus, we have 3a square b, no, we have a plus b the whole cube minus 3ab into a plus b, minus 3ab into a plus b, right? Now, if I'm taking a plus b as common terms from both of these equations, we'll have a plus b outside, and then I'll have a plus b the whole square minus 3ab, right? Now, when I'm extending a plus b the whole square, I'll get a square plus 2ab plus b square, right? Minus 3ab. Now, 2ab minus 3ab would give me a plus b into a square. This would be minus ab plus b square. So that's how we got the equation a cube plus b cube is equal to a plus b into a square minus ab plus b square. Same goes with a cube minus b cube, where we get a minus b the whole cube plus 3ab into a minus b. It would be also equal to a minus b into a square plus ab plus b square. Now a cube plus b cube plus c cube minus 3abc would be equal to abc into a plus b plus c into a square plus b square plus c square minus ab minus bc and minus ca. What happened here? I'm taking a and b and c, right? So if I take a from here, we have a minus ab minus bc and minus ca. If a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc. These are some very important identities which we have to use when we're solving problems. I hope it's clear. Now let's move on to factor and factorization. Now what are factors and what is factorization? So we know that what factors are when, when we are talking about any number, right? When we are talking about the factors of 12, how do we find the factors of 12? We know that 12 is 1 into 12. We could write 12 as 2 into 6. We could write 12 as 3 into 4, right? All these way we could write 12. So the factors of 12 would be 1, 2, 3, 4, 6 and 12, right? So factors is like factorization is the process of expressing a polynomial in terms of polynomials of lesser degrees. That is, if I could write x square as x into x, or if I could write x square minus 4 as x plus 2 into x minus 2, these are called the factors of the polynomial, right? Now, we can do the factorization by different process. First of all, what is happening in the factorization? We have a polynomial with square here, like the degree of the polynomial is 2. Then we are changing the degree of polynomial to 1 here, right? Now, there are different methods to do the factorization. The first method to do the factorization is the factorization by common factors. Factorization by common factors means if we have a term, let's say we have a term 2x plus 2y, right? We could easily write this as 2 into x plus y, right? So any term which have a common thing, we'll just take it out and then we'll factorize, right? Now, there is a method of factorization by splitting the middle terms. So, what do we do in splitting the middle terms? If we have an equation ax square plus bx plus c, right? In this factorization equation, what we do is, first we find the product, right? First we write it in the descending order, where x square is first, then comes x, and then comes nothing, right? And then we find the product of the first term and the last term, right? Now we'll get acx square. Now we have to split the middle term as two terms, right? How do we split it? The sum of them, sum should be b and the product should be equal to AC. In this way, we have to split it, right? Then we'll actually get two terms in the middle and then we'll write the equation. You will understand this more when we're solving the problems, but all we do is like we multiply the first and the last terms and then we'll get a product and the sum. The sum would be B and the product would be AC, right? Now, factorization by algebraic identities. So we talked about algebraic identities. So if you see somewhere an equation like a square plus 2ab plus b square, you could actually conclude that to a plus b whole square, or when you see an equation plus a plus b whole square, you could cut it down to a square plus 2ab plus b square and do the cancelling out process, and you could actually simplify the expression, right? Now that is another method of factorization. Now let's talk about factor theorem. So what is factor theorem? A factor theorem states that if f of x is a polynomial of degree n greater than or equal to 1. So let's say f of x is a polynomial. Let's say f of x is equal to 4x square minus 2, right? Now, and a is any real number. Let's say a is equal to 1. Then x minus a is a factor of f of x. So what is x minus a? Here x minus 1 is a factor of 4x square minus 2 if f of a is equal to 0. What is the condition here? F of a means f of 1 should be equal to 0. So what is f of 1? So f of x is equal to 4x square minus 2. So f of 1 would be 4 into 1 square minus 2, which would be equal to 4 minus 2, which is equal to 2. This means that x minus 1 is not a factor, right? Now, is there any way to find out the factor? Yes. We have to do 4x square minus 2 is equal to 0. So we'll get 4x square is equal to 2 and x square is equal to 2 by 4, right? Then x is equal to root 2 by 2, or we could say 1 by root 2. So the solution of this is 1 by root 2. So x minus 1 by root 2 is actually a factor of this equation where 4x square minus 2 is equal to 0. So I hope everything is clear. Now we talked about, let's go through what we talked about today. We talked about algebraic expressions and identities, where we started from constants and variables, then we moved on to algebraic expressions. Then we talked about the different constituents of an algebraic expression, which are terms. We talked about like and unlike terms. Then we talked about coefficients. Then we talked about polynomials and different types of polynomials, which are monomials, binomials and trinomials, and also quaternomials. Then we were talking about the degree of a polynomial. We found out how to find the degree of a polynomial in one variable and degree of polynomial in two or more variables. Then we talked about the fundamental operations on polynomials. We were talking about the addition, subtraction, multiplication, and finally the division. The division, we did the division of a monomial by monomial, then a polynomial by a monomial, and a polynomial by a polynomial. Then we were talking about identities and we went through some important identities. And then we were talking about factors and factorization. We were talking about different types of factorization, that is factorization by common factors, by splitting middle terms, and also the factorization by algebraic identities. Now, then we talked about factor theorem, where if f of x is a polynomial and a is any real number, then x minus a is a factor of f of x if f of a is equal to 0. In other words, we can say that x minus a is a factor of f of x if f of a is equal to 0. You don't have to get confused about what is f of x and f of a. It's just the polynomials, and it's quite easy once you start solving it. And this is a chapter which particularly needs a little bit of exercises, that is you have to work out the problems. Like when it comes to the chapters like sets and all, the problems are comparatively easier. Like if you read it, you could actually solve the problems. But when it comes to algebraic expressions, you literally have to solve the problems by hand. So I hope you'll practice a lot on these problems. So that's it.